Hi, in the previous video we have been discussing countdown latches and we have come to the conclusion that multiple threads can wait for each other if we use a countdown latch. And a cyclic barrier is approximately the same, so this cyclic barrier is used in situations where you want to create a group of tasks to perform work in parallel, plus to wait until they are all finished before moving on to the next step. This is what we have been discussing for countdown latches. So this is why cyclic barrier and countdown latch are very similar. So it is something like join. When we call the join on a given thread, then it's going to wait for that given thread to finish. And it is something like the countdown latch because it is approximately the same. But what's very important, that countdown latch is a one-shot event. Whenever we get to the point where the counter is equal to 0, it's over, we are not able to reuse countdown latch. But for cyclic barrier, it is quite on the contrary. It can be reused over and over again. Plus, cyclic barrier has a barrier action, a runnable that will run automatically when the count reaches 0. This feature is not present for countdown latch, so basically it's very convenient to use cyclic barriers, because this action, basically this is why we are using countdown latches or cyclic barriers. We want to make sure that we are going to assign every single task to a distinct and different thread, and whenever these threads are finished, we would like to do something. This is what we have been discussing in the previous lecture, that for example, we want to make a good machine learning algorithm. Then we have to download the data. It can be done in a distinct thread. Then we would like to normalize that data. Then we would like to train a neural network. Then we would like to test our neural network, and so on. So this is why cyclic barrier is good, because when the count is equal to 0, then we are able to use this neural network, for example, for predicting stock market related stuff or whatsoever. And of course we are able to instantiate a new cyclic barrier, something like this, and we can define the n, then n threads will wait for each other. And what's very important, this is what we have been discussing here, that we cannot reuse countdown latches, but we are able to reuse cyclic barriers. We just have to call this reset method. Okay, so I'm going to create a class worker. It's going to implement the runnable interface as usual. It's going to have a private integer ID. It's going to have a private, I think that, for example, random, and it's going to have a private cyclic barrier. So cyclic barrier as a cyclic barrier. Okay, something like this. So in the constructor, I would like to make sure that it's going to get a cyclic barrier like this. So this dot cyclic barrier is equal to the cyclic barrier, this dot random is equal to a new random, and this dot id is equal to the id. So sorry, we have to define an id here. Ctrl+Shift+F to auto format, and we have to add the unimplemented method, and we have to import the java.util.random. Okay, so in the run method we would like to do some work, so let's do some work. I'm going to create this method. It's going to be private, it's going to be just fine, and I would like to system out println that thread with id plus id, for example, start the task, whatever. Then I would like to thread.sleep for a random amount of time. So for example, next integer 3. So it's going to generate a random integer in the range 0 and 3 seconds. For example, surround with try catch. Then I would like to print out that thread with id plus the id finished. and we would like to call the cyclic barrier.await. Okay. Of course, it's going to, let's surround it with try multi-catch because it can throw an interrupted exception as well as a broken barrier exception. And I'm going to override the toString method, which is going to return with this dot id, okay, some string at the beginning. Ctrl-Shift F to auto format, okay. And here in the main method, I would like to create some executor service. So executor service is equal to executors dot new fixed thread pool. I would like to create 5 threads for 5 tasks. 5 threads for 5 tasks. And I create a cyclic barrier. Barrier is equal to a new cyclic barrier, and I would like to create 5 parties basically, so 5 threads, and I would like to specify, this is what we have been discussing in a theoretical section, that we can specify a runnable that's going to run automatically when the count reaches 0. So here I'm going to print out that all the tasks are finished. Okay, semicolon at the end. And here I'm just going to create 5 tasks. I is equal to 0, I is less than 5, plus I. I'm going to create an executor service that execute a new worker basically. The ID is going to be the I plus 1 because I would like to avoid IDs with zeros. And the cyclic barrier is going to have the name barrier. Okay, and at the end I would like to shut down the executor service. So executor service that shut down. So I would like to run it, and as you can see all the threads have started, then it is finished because we have slapped for a random amount of time, and as you can see when all the tasks are finished, then the barrier's runnable is going to be called, and that's why it's going to be printed out that all tasks are finished. And what's very important, that if we specify something after the await, then we are able to continue with our work. So after await, and if I run it, then the threads are going to work, then they are going to finish, and as you can see, it's going to be printed out 5 times. Why 5 times? Because we have 5 threads. So we are able to run again some code after the await. Before the await, there's going to be the tasks running. After all the tasks are finished, then this is going to be run. This is how cyclic barrier works. We have the counter 5. When the 5 threads finish with the 5 tasks, the counter is going to be 0, which means that this run method is going to be called, so that's why it's going to be printed out. And after that, we are able to run code that's specified after the cyclic barrier.await method in the worker class that implements the runnable interface. So this is how we can use cyclic barriers, and this is why it is very convenient, because we can specify that okay, this is going to run whenever all the tasks are finished. So for example, we can print out that we are able to use the trained neural network because the data has been downloaded, because the neural network has been constructed, because the neural network has been trained, and so on. So this is how we use cyclic barriers. Thanks for watching.